Hi, and welcome to So You Want to Be a Data Scientist podcast. If you're an aspiring data scientist yourself, don't forget to check the website. It is soyouwanttobeadatascientist.com. On the website, I share weekly articles and resources talking about what it is like to be a data scientist. I also share my insights about what to learn to become a data scientist efficiently. So don't forget to visit the website and subscribe for my weekly updates. Today, I have Víctor García Cazorla with me. Did I say that right, Victor?
Yes, correct.
Great. He's a data scientist at ABN AMRO, which is a major bank here in the Netherlands. He's going to tell us about how it is to be a data scientist in a big bank today. So welcome, Victor.
Hello, Misra. Thanks for having me.
Let's start with our first question. I want to ask you, what happened? Why did you want to be a data scientist?
Well, I guess that it all started in my bachelor at some point. From all the things I was studying in computer science, those things that were related with AI were the most fun. So then that's why I chose my master's in data science. Yeah, it's just so great. You can do so many things with it. It feels kind of powerful. So I guess that's what kept me going in this direction.
So you were studying computer science, you said?
Yeah. So for my bachelor, I studied computer science together with business, and yeah, from those two, I definitely found more interesting the computer part, especially the AI things. Yeah.
Okay, and so for data science, then you started a separate master's degree.
Yes. Yeah, actually, straight after my bachelor, I started working as a kind of junior data scientist in a small startup in Madrid. And there I learned Python. I started doing things with scikit-learn, but it was really, because I didn't really know the algorithms, it felt like really superficial. So I was like, okay, I really want to know what's going on here to exploit it and leverage it. So then after 1 year working, I said, okay, I will just do the masters. Also, it was also at the same time a little bit of excuse because I wanted to go abroad. So it was just perfect. I found this data science masters in the Netherlands. So I said, all right, let's go for it.
Oh, that sounds good. But how did you get your internship as a data scientist if you didn't get any training in data science?
Yeah, so after my bachelor, I was like I said, junior data scientist. I've had some experience with machine learning, but I was using Java with this Weka library. So I guess that's why they hired me. But I mean, I started indeed as an intern, but then I stayed for some months more in this startup. But
Okay.
yeah, I wouldn't really call myself a data scientist back then. But that was when I was really triggered, I think.
So you basically were studying computer science with business, and you decided that data science and artificial intelligence in general was interesting to you. So you learned a little bit about it yourself, and then you got an internship. But now you're a data scientist, a legit data scientist, right? And,
yeah, I like to call myself like that, yeah.
So there are different types of doing data science. Which group are you in? Are you an in-house data scientist? Are you a consultant, or are you a freelancer?
Yeah, I guess I'm a contractor. I think I'm not a freelance, but I'm also not a consultant. I'm somewhere in between.
Okay, but you work in one company, so that's your major part.
Yeah, that's true. Yeah, I only work in one company.
I see. Okay, so let's call you an in-house data scientist.
Yeah.
So one thing I've seen at people who want to be a data scientist in the future is that they don't really have a solid idea of what a data scientist does every day. So that's also one thing I want to ask you. As a person who is working at a big bank, What does a normal weekday look for you as a data scientist? What are some activities that you're doing?
Yeah, I think I can understand this confusion that people who are entering the field might have, because the spectrum of data science is quite broad. Goes from people who are closer to engineering until people who are working directly with the business. My scope entails creating machine learning applications from experiment to deployment, and a normal day to me is I get to the office, arrive at 9. We have the stand up with the team. Each person says what did yesterday, what's gonna happen today, because we are still not that big team as a data scientist team. We still have, basically some of the things that we create, that we put in production, we have to maintain them. So one of the things I usually do in the morning is check that all the things all the models that we have running, if they are, still working, nothing crashed. So I do those checks, and then basically, I work on my project. Usually, I always have one project that I am leading, or maybe two, and some others that I'm kind of contributing. But I always have like the main one big project, right? So depending on which stage the project is, so if it's at the early stage, so it's just I am experimenting with data, or maybe if it's closer to deployment, then maybe I'm doing more. Let's try to make the code more production ready. So my task depends on which stage the project is in. Yeah.
I see. And you said there are always at least one project that you're leading, right?
Yeah.
What does leading mean in that sense? Are you the one person who is responsible from it, or do you have a team of people that you're leading?
I would say it's more like the former. So I am taking the decisions of the directions that the project takes. It's true that if every data science project usually has some common components, so there is always a part of data engineering, and usually I would ask help to our data engineer, but we don't really have one yet, so I have to do that myself sometimes. But it's really, so far it's being a bit ad hoc. So we just try to help each other depending on our expertise. So sometimes I'm not an expert myself in software development, and this is important when you try to deploy something in production. So if I'm doing that, then I might ask for help, or sometimes I can delegate some part of the development.
Okay. So you said it's mostly you maintaining some of the projects that you did before, checking that they're still running, there are no problems, and also you coding a little bit, right? Data science models, preparing the models, or making the code production ready. But what about meetings? How many meetings do you have in a day, or what percentage of your time is spent on with stakeholders, trying to understand the requirements, etc.?
I work. We are basically our team, our data science team, is as like a small startup within the whole company. So our clients are internal. Our clients basically are in the desk next to our desk. So we are always interacting with our clients, and that's usually, normally it takes form in meetings that we have, and in this case, I don't know, maybe per day I might have two meetings, two formal meetings, but then every day I go to their desk many times to just, hey, what do you think of this? It's really interactive. It's very good that we are so close.
Okay, so you have to basically go to them and get feedback more or less every day to update them on what you're doing and also get their input.
Yeah, to define the problem better, also to get their expertise, because they are technical people, and yeah, the things that we develop for them, to solve their problems, which are technical problems, yeah, we really need their input to make sure that we are getting the problem right, and sometimes to get some inspiration when we have to build the features, for example. Basically, yeah, expert knowledge extraction, if you want.
So it's basically you're trying to understand their domain.
Yeah, exactly. Yeah.
That is definitely something I think is underestimated part of data science, is to have domain knowledge. Okay, so your stakeholders are basically sitting right next to you, you said, and you're kind of like a small startup internally in the bank that serves other people who kind of act like your clients, but they're also still part of the bank. But how do you come up with the projects? Who goes to who? Do they come to you saying we need something like this, or do you interview them, try to understand what kind of stuff they need?
Yeah, so this has definitely changed over time. Our team is not that old. Maybe it's depending on how you count, maybe we are 2 years old. At the beginning, our stakeholders, our potential clients didn't really know us, didn't really know how do you work with the data science team, right? Like, okay, maybe I have a data science problem, but what does it mean that I work with these people or that these people help me? So the way of working was really not there. So we said, all right, we need to sort this out. So we made, we sat together, we say, okay, this is how we want to work with our clients. And one of the first things we need to do is to attract their attention. Because at the beginning, we were basically chasing them to solve their problems. We were saying like, okay, let's have a meeting and then you explain me your problems and I will see how I can help, right? So sometimes it was like this at the beginning. But after some successful projects, we have definitely got the attention of the clients in the department that we work, and now we're at the point where they do queue up at our desk. They come, hey, nice. Because they know us, they know from previous projects that we have done which type of things we can do and which we cannot, right? So they at this point they do come with the problems. Sometimes they are not sure if we can help, but they still come and we sort that out with them.
Okay, so it's basically took a while for them to be confident in you, but probably also data science itself.
Yeah, exactly. Indeed, also data science itself, because they are at the beginning some of the clients sometimes were a bit skeptic about what is possible with data science and what's not. So it's like a seed that is growing inside the bank, I would say. And it's very nice to see how data science is being taken more and more into account as time passes. So that's definitely a good thing.
Yeah. But it's great that you managed to do it, and now people are queuing up in front of your desk.
It's really great. I think that it's really key to at the beginning try to do a couple of successful things and then show off in some presentations, so the thing starts to shine, and then they will just come at you because they are interested.
I guess the other people start talking about the shiny new data science project they have, and then other teams get jealous and excited. They want a piece of it too.
Yeah, exactly. Sometimes it even gets to the point that they are like, all right, now we got this new piece of data. We want to do something with it. We want to do something nice, right? So maybe they don't even have a problem. They just want something with data. So that's see that from their eyes is like a shiny thing that has potential and they just want to use. This is also maybe not that good, I would say, right? You should have a problem to solve, right?
Yeah, but when you think about it, sometimes even just writing a couple of lines of code, or even maybe without code, just visualizing some piece of data is really valuable in terms of giving your client some insights, because maybe they've never seen that chart before. So when you look at the steps of a data science project, what percentage of your time is spent on which one, would you say?
Yeah, of course, the majority will go in the data acquisition and the data cleaning. But this depends. For example, for data acquisition, so there is the data source that we need you need the data from. If I have done already some projects with that type of data source, I already know how to query it very well, so then I would spend less time doing that. But yeah, I think that the cleaning is a part that is is the one that takes more time, I would say. Okay, to give some estimates, I would say cleaning maybe is 30% of my time, then maybe 20 is for the data acquisition that would come before, and then the rest goes into experimenting with the modeling and then deploying.
Okay, so you said half your time is spent on pre-processing and also acquiring the data, and half your time on adjusting the model. How do you go about doing that? How do you adjust the model? How do you work on the model?
So this of course depends a lot in the problems that you are tackling. In my case, I usually try to solve security problems in the cybersecurity world. So detecting cyber attacks, but also financial fraud. So detecting money laundering, human trafficking, all these things. So there is one common factor in all these problems, and is the lack of labels, or at least highly unbalanced data sets, right? So it's only in 0.001 of the cases you will have a positive. You will have that, from all the emails that we get in the bank, incoming emails, is really tiny fraction will be really malicious emails that try to steal something. From all the transactions that we receive, only a small fraction will be related with some fraud activities. So we're dealing with this, this lack of labels. The fraction of the things we're after is very small, but oftentimes we don't even, maybe we just don't have labels, right? So that already puts several constraints on which type of things can you model. So supervised learning is something that we don't really, is not that common here. We don't use it that much. So we do a lot of unsupervised modeling, and this is quite tricky, right? Because you have to define your features. So you never have the label that you're after. That phishing email, you don't have that malicious transaction. But based on the knowledge that you get from the expert, you can you start building features, and these features will resemble like some pattern that you're after, and then maybe you have built several of these features, and then you still need a way to combine them. So sometimes you say, okay, I will just run an anomaly detection algorithm on top, but other times you try to kind of build a score with some rules. So it really depends. But usually the way we do it is we take one decision regarding one design of the modeling. We say, okay, we do these features and with this algorithm then for anomaly detection. So then the model will produce an output. Would say, okay, I think all these transactions that were not flagged are actually part of a financial fraud activities. So then we get the sample and we send the sample to an analyst, expert, and then the expert will go through this list and will tell us, hey, your model is really is a bit bullshit. We don't like it, or maybe it says, oh, actually, yeah, the model is right. We missed this, and it's interesting. So then it's based on this feedback. So for example, if the feedback is negative in the sense that, yeah, the model is not performing well, we might have a second chance because of course this is very time consuming for the analyst. So sometimes we have a second chance and then we we can change our design and then try again. But yeah, because it's time consuming, we don't really have those many trials.
Yeah, so it's no wonder that it takes you half your time, because it's such a labor intensive process to send it to an actual person and have them to validate your results. But I'm sure it's really rewarding when they say, yeah, this is a pretty good model.
Yeah, it is. It's really a rewarding moment. Yeah.
And so you talked about some of the projects that you've been dealing with. What do you typically deliver at the end of these projects? Is it a presentation, or do you deliver a pickle file, which is a model?
Well, yeah, definitely. I think not a pickle file. If I would give a pickle file to my customers, they would be like, huh, "What's this?" But yeah, it's usually, yeah, we try to build full applications. So if our
from start to end.
Yes, end-to-end applications that will just provide an API so that our customer can use. So if our customer wants to know which transactions are fraud, then we would build a full application in our own environment, in our own data science environment that the customer maybe doesn't even know about. From our environment, we have everything. We fetch the data from the database, we execute the pipeline, and then we would basically say, well, the pickle file, the trained model resides in our environment, and then we open the API that the customer can say, okay, tell me if this transaction is fraud, and then our model says, okay, yeah, it's fraud or it's not. So it can be, yeah, an API, or sometimes we are just providing a feed, a logs, so that we provide the data ourselves. So yeah, but other times it's true that just a presentation with some insights, yeah, it's welcome for the client. It's usually not the end of the product usually. And sometimes, yeah, we also create dashboards for our clients.
Okay, so it depends from project to project, basically.
Yeah.
But you said you also deliver some end-to-end products, so I'm guessing that at the end you also have to act like a data engineer, because data science is mostly about the analyzing of the data and preparing the model, but then you also have to create the API yourself.
For that, we have a machine learning engineer that takes care of that part. And then, yeah, and then on the other extreme, so at the end, I would say at the API part, the deployment part, we have the machine learning engineer. But then at the beginning, in the data acquisition, we have the data pipes set up by the data engineer. And this, of course, depends in the maturity of the team. So when my team was even smaller, sometimes I had to do the whole thing. But as we grow, we start to specialize more in our roles, and then this division happens. And then in that case, I would only take the part in the middle. So the engineer will make the data available for me, and then the machine learning engineer will know what to do with the results that my model produces in such a way that the end user can consume these results.
That sounds good. So my last question for you for today is about the tools that you use at work. What are the tools that you use the most?
Well, if the programming language is a tool, then Python, and then we have been using Jupyter notebooks for a long time, but now we are starting to use Databricks. So that's it's like feels like Jupyter notebooks, but it's a bit more. So one of the drawbacks of a Jupyter notebook is that you can do your experiments very well, but then if you want to deploy, you want to transform your thing in your notebooks into an application, that you need to do a lot of extra work. You need to turn those notebooks into Python scripts, and there's a lot of work. And now with Databricks notebooks, you still get to work your notebooks in a just like as if you do in Jupyter notebooks, but then the transition to deployment is way easier. So now we are starting to use this one. And then when it comes to creation of dashboards, we use Power BI.
Okay. Any other visualization tools do you use?
No, not really. So it's just Power BI, and then for the in the experimentation part of the projects, then from Python we do the visualizations, and for this we use Matplotlib or Seaborn.
Yeah, of course. And do you use any database languages, so querying languages like SQL?
Not really. It depends on the data source that you use, right? And in the bank, in the security world, we work with log data, so from machines, for example, and we have Splunk. Splunk is a database for this type of data that comes with its own query language, which has some similarities with SQL. Yeah.
Great. So actually, I have one last question for you. It is not really a question, but it is I'm going to ask you for some advice for our listeners. Is there anything specific that you would tell an aspiring data scientist?
Okay, so my advice would be, it sounds really sophisticated, all these AI things that it's in the news, but I really encourage people to come to the field. It's very fun, it's very rewarding, there's lots of work to be done, and even though it sounds hard, I think the industry is creating more and more tools, is really going in the direction of making this easier and easier. It's making the deployment, the productionalization of your experiments easier. So you don't need to be an expert software engineer. As I said, with tools like Databricks, the gap between the notebooks and the deployment is becoming narrower and narrower. And at the same time, when it comes to all those complicated math algorithms, we are also abstracting them away. So basically the world of applied machine learning is becoming more accessible to people. So I really encourage those who have any interest in this to just go for it.
That's great. Thank you for that encouraging words. Yeah. That's really helpful, I think, also for aspiring data scientists. I get a lot of questions and from people saying, they have a background in marketing, for example, and they don't feel qualified enough, and they feel like it's already too late for them to get into the world of data scientists. So for those of you who think that, listen to Victor's words. So that's really useful and encouraging. So thank you. That was my last question, Victor. Thank you for coming on the show today and sharing your insights with us.
Yep, it was my pleasure.
Great. And scene.